Hi everyone, here with an update on my Boeing 737 overhead panel project with the x737. As you know, this is a freeware program, so it's a very nice looking model, pretty well modeled inside the cockpit too. Here we are in the cockpit. I'm going to show you what I've been working on. As I said, I was going to start with the gray panels. They're the panels that have the major systems that are affected, that really the most important systems, and they're affected by the fire shutoff handle when you pull the fire handle. That includes over here the pneumatics, the hydraulics, the electrical, which I'm going to show you in a minute here, and the fuel panel. Now those are the main panels that I've worked on so far, and then I'm going to build in around them. Now it took me a while to get this done. I've been distracted by a lot of other things in life in the last week or two, but I do have the panel. I want to show you what I've done. This is the panel that's the electrical panel, and right now all the generators are off. Now these blue lights in the electrical system down here, there's, as you can see, there's similar to the fuel system and the pneumatics and everything else, because there's two engines, there's kind of a redundancy. We have a left generator that's engine driven that powers a generator bus and then on up to a transfer bus. Then we have a right generator, engine driven generator, and it's powering that side, it's part of the equipment on that side. And then we have an APU generator, the little jet engine in the tail that produces electrical power. And that system, as you can see from the diagram, can be used to power either side. Now right now, these little blue lights tell us that the generator is not on the bus. In the case of the APU, it's telling us that it's operating and it's up to speed and it's available. Now, I already started the APU for that purpose. So the way these switches on the bottom, they're momentary switches. They're spring-loaded to the center position, as you see here. And then to turn a generator on, you have to, I'll first show you over here, you pull it down and release it. If you want to turn it off, you pull it up for a second momentarily to break the contact and release it. But the switches are normally in the center position. Ground power switch operates the same way. Now, when we put this generator on, you can see it powers the generator bus and the transfer bus, and it also powers this transfer bus on the other side. Now, I'm going to turn this generator on, and now you can see everything is powered. Now, the APU can also power either bus. As I said, the APU is up to speed and available because the blue light is on. So what I'm going to do is I'm going to turn on the generator connector on the left side here, and you can see what that did was it connected the APU to this side. The generator off light is on because this is what they call all the Boeings use a break before make is what they call it. It breaks the current connection before it adds the new power, because this is AC power and you don't want different frequencies, different cycles coming together. It could be bad. So it always disconnects what's the current source before it adds the new source. Watch what happens if I turn the generator back on. You see it broke the connection for the APU and then turns on the generator on this side. There is a bus transfer, and I had to figure out how to model these switches. I decided to go with you click on the guard, or I've designed it for touch control. Actually, that's the way I hope to use it. But anyway, click on that, and that opens it, and then the switch is available. And then when you want to close it, just click on the guard to close it. All the guarded switches are that way, and I'll be able to use that the code that I wrote for that to operate all the switches later. And some of the other panels have guarded switches also, flight controls and so on. Now, the ground power, the way he's modeled X737, if you click on the ground power enunciator, it's equivalent of plugging the power an operating power card into the airplane. That just gives you an easy way to add ground power without having to go through some external switch. So I'm going to click this and the light comes on, and that tells me the power's plugged in and is good quality. The 737 checks the power quality of any of the connections before it allows it to connect. It won't allow you to connect a under voltage or over voltage or a under or over frequency power source to the system. So that's available. Now if I turn that on by holding that momentary switch, again it will go back to the center, and you can see now it's disconnected everything. The ground power is connected through the ground service bus to all the buses. So we disconnect the APU, generator 1 and generator 1 and generator 2. Now if I turn the generator 2 on, you can see it disconnected the ground power. This side of the airplane is still unpowered because that generator is not connected and I didn't connect the APU. Now on the ground you can power both sides with the APU. In the air it will disconnect. Actually you can take off, but in the air it will not allow you to connect both sides to the APU. It should only allow you to connect one side to the APU in the air. But if you put it on the APU and forgot to put the generators on and take off, it will leave them connected because it doesn't want you to lift off and then lose power, something like that, electrical power completely. So it will allow those to be connected. As I said, the bus transfer just inhibits that transfer. You see there's a transfer bus here and a transfer bus here. Power can be transferred across from one side to the other, but if you had a fire or something, electrical problem, short or something, you might want to inhibit that. So that's what that's for. Now working our way on up, we see there's two switches. They're the internal generator disconnect switch. The original 737 used a mechanical constant speed drive unit, but now there's an IDG, integrated drive generator, or generator drive. I can't remember which way it goes, but anyway, this provides a way. See, the engine can run at any variable frequency, so you can't just hook a generator up or you'd have variable frequency. So you need some way to get a constant speed to make sure the generator is producing power in a constant way. Now in the original 737, 200 and 300 up through the 400, those were even the classics of 5 and 6. Those were anything before NG. They had a constant speed drive unit that it was basically, think of it as a little hydraulic, almost like a constant speed transmission, if you will, a fluid driven thing that would maintain a certain frequency so that the generator would turn at a constant frequency and produce power. Now the newer units can do that electrically. It's not quite as big a problem, and it's lighter weight and it's integrated into the engine, but it does the same thing. Now there are occasions when that can fail and you want to be able to turn that off, and you do that by opening this guard and pulling this switch, flipping this switch up. When you do that, it permanently disconnects the generator from the drive unit, and that's it. There's no resetting it in the air. You've lost that generator for the rest of the flight, and you know, depending on whether the APU is working, you might have to get on the ground right away. Basically the rule is, if you ever get down to just one generator, and like if you lose a little generator and the APU is working, you can use the APU and that's fine, you can press on. But if you lose a generator and the APU, or if you dispatched without the APU and you lost a generator, then you have to land at the nearest suitable airport. You can't just fly onto your destination that way. So basically, for electrical systems, you need to have a backup at all times, and anytime you're down to one system, you got to get it on the ground. Just the same as the engines. We have two engines. If we lose one engine, we have to get it on the ground. That's basically a system with the hydraulic systems too. You're going to want to be aware that anytime there's not a backup left, it's a kind of situation wanting to get on the ground. I'll flip the switch on the disconnect, and you can see the drive light comes on to tell me that it's been disconnected. Also, when the drive overheats, there's other times that this drive light will come on when it's still connected, and generally it will auto disconnect if it has a problem. But once, like I said, you can flip the guard back down, but that thing is disconnected and it's not being reconnected for the rest of the flight. Final thing we'll look at here quickly is the standby power off. Now there's a standby power system. This is very important. These are flight instruments, basic navigation, it's just limited amount, mostly captain's instruments. It won't run the whole cockpit, but it'll run the most critical equipment. And if you have a total power failure, what this does is it makes sure you get power to those critical instruments immediately. Now, it's normally in the auto position, and in the auto position, it will automatically transfer to the battery, to the standby power bus. If you lose if you were to lose power, the primary power to those important systems. If you want to, if you need to, there are occasions where you might want to turn that off, again with an electrical problem. There's also times, and you can see that when you lose standby power, this light comes on. Now if it's in auto, it should automatically transfer. And then you can also select battery. When you're in battery, you can see we do have standby power, but it's forcing it to use the battery bus to power the standby buses, and it can't get it from the transformer rectifiers, which are the little inverters, if you will, that take they basically take the AC power and convert it into DC power to run these DC standby instruments. So the transformer rectifiers, the standby bus can be forced to go to the battery, or if those are not, and auto is the normal position for that. So that gives you an idea of what I've done. Not too much this week, in the last week and a half, 2 weeks, but I'm going to try to work, I think, next on the APU panel, which goes right below this. As you can see, there's not a whole lot to that. It has 4 lights, an overspeed, fault, low pressure, and maintenance, a gauge, and one of the windshield wiper switches is on that panel. So I'm going to try to model that, and then I'm going to try to give it a shot for the next thing I think I'll do is the electrical meters up here. It has the battery switch and abilities to check different settings on the meters, and there's a few warning lights up here too. So we'll see how that if I can do those in the next week or so, and that'll pretty much complete that whole panel. And there's four vertical corridors, if you will, or columns, and then this let me get rid of this. As you can see, there's a center that has some no fasten seatbelt lights, emergency exit lights, some lighting controls. That's not a whole lot. But this electrical panel, I'm going to try to complete that, and then we'll probably go over here and get the pressurization and the air conditioning controls, and it'll come along. It's going to be a little while though, so don't hold your breath if you're waiting for these. And we also got to figure out how to find a big enough touchscreen to get all this on there, and I'm thinking it's going to probably have to be at least a 40-inch. So I'm looking at sourcing some IR touch overlays that I can put on I'd like to put it on an HD TV if I could. Not HD, but a UHD 4K TV, so that we could have really good resolution and we'd be able to run these panels at the size that you're seeing them on the display. So stay tuned, and I'll give you another update as soon as I get another panel or two completed. Thanks for watching.